When I first got into Cisco, one of the things that threw me for a long time was the output of show interface. I knew there was a bunch of stuff there that I needed. I knew it was all good stuff, but I just couldn't put all the puzzle pieces together because there was so much info. So what I want to do here is go through the show interface command and show you what is relevant. Essentially, here's what you need to know to troubleshoot interface issues on a switch, both for the exam and, of course, the real world. So let's do this. I'm going to do a show interface fast Ethernet 1/0/13. Got a device plugged into that port. So here's our typical show interface output. I'm getting my magic maca ready to go. First thing I always look at is this line right here. Fast Ethernet 1/0/13 is up. Line protocol is up. That's the physical layer of the OSI model. That's the data link layer. Typically in the Ethernet world, I'm not going to see any kind of issues there where one is up and one is down. That's usually in the serial world where I've got like a PPP to HDLC mismatch or something, but that will tell me if it's up or down or administratively down where it's shut down. I can also see real quick on that connected place if this port is error disabled. I'm planning to do a nugget later on how to handle those error disabled ports. But once I see that this is good, okay, I go right down to here. Number one place errors occur, full duplex, 100 megabits per second, and media type, etc., etc. Essentially, here's a little known fact. Auto detect, right? If you remember in CCNA, I talked about auto not use it, where you hard code speed and duplex. Well, if you do that, you must do it on both ends of the connection. So here's a switch, right? If I go in and hard code this server to 100/full, and this side is set to auto, I am guaranteed that it's going to negotiate 100 megabits per second half duplex because that is how the Ethernet standard is written. The auto detect mechanism essentially communicates to this side, and this guy does not reply because he's hard coded. So this guy says, well, I haven't heard back. I'm going to default to the Ethernet standard back when 100 megabit per second was first released and half duplex was all over the place. I'm just going to do 100 half, right? Same thing happens if I hard code the switch side and leave the server on auto. Again, I'm guaranteed to have a duplex mismatch. So that is the number one place issues occur. Best case, you get that error disabled port because you get so many errors. I say best case because at least the interface goes down and you have to do something about it. Worst case scenario, it lives on and you always have that server that's really slow and nobody really knows why. Next thing I look at, I drop down a few lines to right about there. Last clearing of show interface counters, never. So what that tells me when I'm looking at all of the stats below is these have never been cleared. Now, keep in mind Cisco switches can run for years without rebooting if you connect them to a proper UPS power backup, right? So a lot of times people will log into a switch, do a show interface and see, something like 900 interface resets, and they're like, bah! And they freak out. They're like, something's going on with the interface. But it could have happened a year ago with a bad cable or somebody unplugging or whatever the case is, and never have anyone cleared the counter. So first thing you always do is clear those things out. I think it's a clear interface counters or clear counter interface, one of those two, so that you can see if that error is still occurring. Then drop down a couple lines, or actually one line, to the input queue. Essentially, the interface on Ethernet switches, or I should say the engine behind it, is all ASIC based, application specific integrated circuitry hardware. There's essentially hardware components inside of this switch that allows it to look at that MAC address and bam, move the data through it at wire speed. So if I'm seeing things queue up, the first thing I'm going to say is there's some kind of speed mismatch. Do I have like a gigabit port that's trying to transmit out on a 100 megabit per second interface? Because essentially the queues should not really have anything in it. Or I'll look, is there a bunch of output drops, meaning the switch was trying to send something, it didn't have the ability to, so it ended up dropping the interface or dropping the packets. That's typically indicative of a speed issue. From there, I drop down to the nitty-gritty detail itself. That's down here. Now this right here is a little bit handy. You can see what's happening currently over the last 5 minutes with the switch, to where you can see, is this active? Am I receiving data? Am I sending data right now? But mainly, this is where the nitty-gritty stuff comes in. I look at the number of broadcasts. If I see a ton of broadcasts relative to the other data that's down here, I'm going to say, okay, is there some kind of loop that's happening? Am I seeing, a broadcast storm occur before me? I'm going to look at the runts and giants. I know that's kind of a weird one. runts, if I see a whole bunch of runts, essentially what that means is I'm receiving packets that are too short. Essentially, the RFC standard says data should be at least a certain length. A runt is where it receives a packet. It's kind of like, it's going to be kind of gross, but anyone as a kid, torture ants? You've got like the, the little, come on, we're all, I was gonna say we're all guys here, right? We all no. There's all kinds of people that are listening to this right now. But you get the ant. As a kid, what do? They got the little. This is anyway. You probably know where I'm gonna go with it. You sever the ant. It's not meant to be that way. You can't do that. You can't do that to ant kids. So what a runt is essentially essentially a runt is a severed packet. Now, how did it get severed? Well, essentially you've got this switch here connected to, is it another switch, another device down here? So essentially that means the other device that was sending it at some point started to send, and then it's like, oh, stop sending. So if I see a whole bunch of runts, what that means is I'm seeing the switch down here that's stopping sending. Why would it stop sending? That means that this guy is likely a half duplex. HD, that's not good, and it's not high def. It's half duplex down here where I'm sending some data, and this guy's configured as half duplex, so it's like, oh, it starts to send and it stops, so you get this severed packet that is received over here, and that ends up being logged as a runt, and typically will also show up as an input error. So runt is essentially a severed packet, and by the way, that's immediately what makes me go look at the other side and say, okay, is there some kind of duplex thing going on here? Input errors is generic, so if I see a whole bunch of input errors without any runts, I'm usually going to say, okay, is there something wrong with this cable? I know, first off, I will say there are a lot of people say, oh, that must be a cable issue, and it's not. That's like, very rarely do I see cabling issues, but they do happen. To where you just get a bad cable. It's just, bad copper, bad something. And you're getting a bunch of input errors for no good reason. So one of your steps is, can we replace that cable? I've also seen a bunch of input errors whenever you have a switch that's configured. Let's see, where did I see this? Like this. You've got this guy set up as a dynamic port, right? Dynamic trumping protocol, switch port mode, dynamic desirable, the default out of the box on a lot of switches. And then on this side, you configure this as no switch port, right? It's a layer 3 interface. A lot of times you just do that because you're configuring some kind of layer 3 interface and maybe you're communicating through this to another port. Well, this guy's going to log. Is it this side? Yeah, no, this side's going to log a whole bunch of input errors because it's going to be receiving the DTP packets from the other side, and it's going to be like, I don't know what those are. I'm a layer 3 interface. I've got no switch port. I'm dropping. I'm actually logging those DTP errors or DTP packets as input errors. So you might want to check and make sure that this side is configured as switch port mode access to make sure it stops sending those DTP packets. So next thing I look at, I know it seems like a lot, but really I'm trimming down all this input into the key things. So I'll hit that at the end. So next thing I look at is, relatively speaking, packets output and packets input, just because it gives me a perspective. For instance, if I see 5,000 input errors, I'm like, oh no, and then I see 15 billion packets input, I'm like, oh, well, that's perspective. That tells me that we're probably good. It's just this thing has been running for a long time, hasn't had the counters cleared or anything like that. Down here, late collision. That's a big one. Late collision happens when essentially a packet collides later than the Ethernet standard should allow it to. That a lot of times indicates a duplex mismatch, meaning you've got one side half, one side full. This guy is sending, and all of a sudden, much later than typically an Ethernet switch would or an Ethernet hub would happen, a collision occurs. Just from the way CSMA CD, that's the Ethernet standard, works. Essentially, if you're going to have a collision, it's always going to happen within the first 512 bits of data. So just based on how the timers work with this thing, as it's sending, the collision should occur, or essentially one of these should be logged if you've got a truly colliding hub on the other side within the first 512 bits. If that's not happening, it's considered a late collision, which almost always indicates one of two things. One, you've got a duplex mismatch, and you can see a lot of times, that's why I'm saying almost always this is the culprit, or you've got an Ethernet cable that's way too long. 328 feet if you're American, or 100 meters, which is a lot easier to remember if you're everywhere else in the world, is the maximum distance of that. Now, people start realizing as they're in the real world, we can stretch that standard. It's like the Matrix. Some rules can be bent, others can be broken. And I see this happen all the time. You're doing a long run and you're like, we can make it, we can make it. You plug it in, the light turns on, you do some ping tests, you're like, we're good. Right? Well, you might end up running that thing too long to where acknowledgments come back or keep alives are happening that just take longer to get there than you would think, and that's where you also can start seeing late collision messages come up. Really a big picture indicator of line quality in general. Last one I've got is this guy. Last two I've got. Giants and interface resets. Giants occur if you've got one side configured for jumbo frames and the other side isn't. Normal Ethernet standard says that the maximum transmission unit should be 1500 bytes. Well, as you start getting into virtualization and running all kinds of stuff through the switch, they're like, hey, we can make this a lot more efficient because our switches are awesome nowadays and they don't have many, packet drops or things like that. We don't need to split our data up so much. So we can create these jumbo frames, meaning frames that can jam in 9,000 bytes of data, typically used when you're running virtualization, where you actually have like a VMware ESX server running up here and maybe a SAN down here, which is having the hard drives of all of your servers. And so literally you've got a server that's accessing its hard drive across the network, right? Well, they find a lot more efficiency can be gained when you turn on jumbo frames, which jam those in. Well, if you don't have a switch in the middle configured to support jumbo frames, you're going to start seeing these giants being logged, meaning things that exceed the Ethernet standard. So you want to fix your jumbo frameness, right? Last one is interface resets. Interface resets occur when the interface resets. A lot of times if you have too many errors happening, sometimes the switch will come in and perform an interface reset to try and clear things up and reset the connection. Or if obviously you've got a flapping interface going up, down, up, down, up, down, up, down, you'll see a lot of interface resets occurring. So check that out. I've seen a lot of interface resets occurring when you get those transceivers, which are becoming, thankfully, fewer and fewer. Transceivers where you've got a long fiber run, but you didn't have a switch with SFPs or fiber interfaces. So you get a little Ethernet to, or I should say fiber to Ethernet converter. These things are so flaky. Anyone with experience with transceivers will be like, get those things out of there, because they cause so many problems. Some of them, even the higher quality ones, just over time just kind of break down. So get them out, get a real fiber module for your switch, and jam that fiber optic cable right in there. So I know I've been talking a little while on these interface counters, but can I just do a recap for you? Again, quick glance. When you get too far into the nitty gritty, it feels overwhelming. So let me just kind of bring you back up for air. Okay, quick glance, show interface. Check and see if it's up. Check the duplex. Do we have any kind of half duplex connection coming in there or not? Check the interface clear, meaning how recent is the statistics that I'm going to run into down here. Usually I don't even look at the queuing because that's essentially ASIC based, so I shouldn't see any issues there. Then I come down and I go, okay, let me look right here. What am I seeing on the input errors? If I see a high number there, I'm going to check in my runts, in my giants, am I seeing a bunch of large packets or super small packets? Do I see a whole bunch of late collisions, which almost always indicates a duplex mismatch on the interface? And at that point, I'm done. Right? That's a quick scan of those interface counters, the key areas that I'm looking for. I hope this has been informative for you, and I'd like to thank you for viewing.